Good morning, everyone. Good morning. All right. Thank you guys for coming out to this session. I'm super excited to be here this morning with you guys, mostly because I plan to get all of my questions answered about AI today. So it's really good. I don't know about you, but I feel like I was beaten over the head with AI this week. Every session, somebody was like trying to slip it in. It may not have fit. Sometimes it fit, sometimes it didn't. But I definitely felt like I got the message. AI is a strategic initiative. We should all be thinking about AI. And Gartner even declared it as one of the top strategic technology trends for next year. So I know that we're going to keep hearing about it. And so I thought it would be great to bring a really distinguished panel together today so that we could get all of our answers to some of our questions around AI. And it really stemmed from a conversation that I had with Gartner probably 3 months ago, where they shared with me that about 90% of the inquiries that they get around deep learning and machine learning are still on the data side. And it's really, people are trying to figure out if this is hype or if it's real. And so I wanted to be able to put together a session that addressed those 90% of inquiries that we're not ready to talk about algorithms and FPGAs and ASICs and inferencing, and really wanted to understand how they got started. So today I've got a very distinguished group of guests, and we're going to go through, and I'm just going to have each of them introduce themselves. I'm Kim Storin. I'm the VP of Marketing at IBM Cognitive Systems, and I'm probably the least technical of the folks up here, so I understand how some of you feel that are starting to dip your toe in the water, but I'll go ahead and introduce Sumit.
Yeah, my name is Sumit Gupta. I lead the HPC and AI offerings in IBM's Cognitive Systems business.
Nadeema Asghar, I'm the field CTO, and I run partner engineering globally for Hortonworks.
I'm Sam Charrington. I'm founder and principal analyst with a firm called Cloud Pulse Strategies that helps organizations understand machine learning and AI and how to apply them. And I'm also the host of a podcast called This Week in Machine Learning and AI that you should all listen to.
Hi, and I'm Charlie Boyle. I run our enterprise deep learning systems group at NVIDIA, and just seen tremendous growth in the space this year. So happy to be here and share some insights with you.
Great. So let's get started. I've got lots of questions. We're also going to leave some time for you guys to ask questions as well. So if there are things that come up that you're interested in, get ready. We'll throw the mic around with about 10 minutes left. But I wanted to start out and kind of going off the comment I made before, where I felt like AI has really come into every conversation here at Gartner. Sam, coming from the analyst perspective, is AI hype or is this real?
I think of AI in the context of other emerging technologies that we've seen, like cloud and big data. And I think that, there's certainly an exuberance that has come into the market, and we saw the same thing with cloud, but we also saw that organizations that really dove into cloud, for example, and used it not just to extract some CapEx out of their operations, but to really transform the way that they engaged with the marketplace, had huge advantages. So we have to be careful of, the hype and understanding vendor claims, but at the end of the day, you have to ask yourself, do you want to be the Netflix or the Blockbuster, of AI? And I think it's, all organizations really need to take it seriously for that reason.
What do you think sounds the most promising or most useful to you right now from where you sit?
I think it's a little bit difficult to answer that without first exploring some of the differences between machine learning and AI. And I say that because a lot of the things that are most promising and most practical for organizations today are really relatively simple machine learning types of applications. But a lot of what people think of in terms of AI are things that, some people say that AI is machine learning that looks like magic. Like we don't really understand it yet. It's, it's computers that can, on our phones predicting what we're about to type, things like that. And from an AI perspective, a lot of the excitement in the industry right now is in and around a technology called deep learning that is really, put very simply, take tons and tons of data and throw it against a neural network, and that neural network will figure things out about that data and that can be used to make predictions and interpret the data. And so in terms of applications of that are really interesting, there are a few. One is we've made a lot of progress in our ability to interpret images. And so if you think about like from a consumer experience, Facebook has been able to tell you who's in a photo for a long time. But now organizations are getting the capability to interpret business images as well. So there are companies like there's a startup called Matroid that will allow an organization to take video feeds and identify objects and brands in those video feeds. There's a company called Affectiva that can take photos and videos and determine emotional content from those photos and videos. And then there's applications like doing quality control of products that are coming off of a production line to make sure colors and textures are correct and everything is within tolerance. And this is all from image data. And we're seeing similar advances in terms of natural language and text, like Amazon Alexa and what we see on our phones with Siri and the like. And then the third is an area called deep reinforcement learning that is like it's kind of the furthest out of these three. But reinforcement learning is really the ability to train intelligent agents that can kind of optimize their behavior relative to some goal in a changing environment. And so it's a very promising area because it has very broad implications in fields like robotic control and supply chain optimization and marketing resource allocation, tons of interesting use cases.
Excellent. So let's do a quick show of hands. How many of you guys in the audience are currently using deep learning, machine learning, or other AI technologies in your company? And I'm not talking about like Bixby and Alexa and Siri, right? I'm talking about real enterprise AI. How many of you guys are thinking about it, but haven't yet actually started putting the applications in place? Wow, that's a lot of people. Excellent. So then, kind of knowing where most of the room is, Sumit, I think, you dropped, Sam, a couple of words like deep learning, neural networks, deep reinforcement learning. Maybe Sumit, if you can take it back a bit and kind of start with the basic 101, like what are the real differences between deep learning, machine learning, and some of the other terminology that's out there in the industry?
Sure. So, if we just start with the high-level term, which is AI, AI is very simply making a computer mimic humans. That's what AI is, right? So it's a catch-all term. The way you can make a computer mimic humans could be Google Voice, Apple Siri. It looks like you're talking to someone. Now that, obviously not a very interactive discussion right now, but they're getting better. They can actually understand you really well. But the real subsegment of AI, the real technology behind that, is the broad field of machine learning. And machine learning is algorithms or computer models that learn from history. So let's say you have a bunch of data and you look at the data and you say, well, I've seen this before. And whenever this happens, history tells me that if X happens, Y will happen. Target is famous for having implemented all kinds of analytics around customer buying behavior. So most retailers today will place items next to other items because they know that when someone buys bananas, they buy milk, right? When men go to buy diapers, they buy beer. Fact. But this is machine learning where you're looking at historical information and then making a decision based on the new data that you just got. I now know that something happened in the past, which gives me some knowledge. Deep learning, as Sam was suggesting, is a brand new method within machine learning. So it's a subset of machine learning. And it's really a 50-year-old method which was reinvented a few years ago. And this is the reason why there is so much hype or interest, or why are we talking about AI this year and last year at this same conference, it was mentioned but not really talked about, is because deep learning took off in the last couple of years. That has been the true revolution. So I love to plot this, I love to show this chart, which is just the number of Google searches on deep learning in the last few years, and it is the proverbial hockey stick, right? The reason why people are so excited about deep learning is it is extremely accurate if you give it a lot of data, right? That's the catch. Give it a lot of data and it's extremely accurate. And deep learning, Sam mentioned it's neural networks, but at a very conceptual level, it's very similar to how we learn. So when we teach a baby to recognize a dog, we show them an image, or we show them a dog, then we show them another one, and another one, and another one. And one day the baby says, dog. The baby isn't thinking if has 4 legs and tail wags, therefore is dog. The baby is perceiving a dog. And in fact, if you don't show the baby a cat ever before and they see a cat, the baby will say dog. Because the baby actually has begun to recognize animals, not dogs yet. Right? So that's why you show counterexamples. You show cats, you show horses, you show other animals. So the baby then distinguishes, there's a concept of animal which has these other concepts. That's pretty much what deep learning tries to mimic. Deep learning, the actual algorithm itself, is a black box. It knows nothing about nothing when it starts. And then you start feeding it a lot of data, and it starts just finding the most interesting aspects of that data and then making predictions based on it.
Interesting. So, Charlie, I know that NVIDIA, speaking of deep learning, right, NVIDIA is one of the leaders in deep learning. What are some of the use cases that you're starting to see, building on what Sumit was talking about in terms of those differences? What are the use cases where you start to see deep learning really coming to life for the clients that you guys work with?
Yeah, I mean, it just exploded in the past 2 years, and this year I think we've seen people go from concept to implementation. So we've seen retailers using real-time video for inferencing to make better marketing decisions, better targeting. We had a great example yesterday in the panel with IBM in healthcare and radiology. We all probably everyone in this room has had an X-ray. A lot of people in this room have had other types of scans. The ability for deep learning, huge images, to look at that and say is this healthy? Is this person okay? Do you need to look at it more? I mean, it's a fairly simple thing, but it has huge implications in medicine. If you can quickly determine in less than a minute, somebody should look at this versus put this in another pile. This person is 99.9% okay. It seems simple, but that's going to save a lot of lives. On the enterprise side, IoT, industrial inspection, manufacturing, everyone that's building a product, us included, as you're putting those products out of the line, you have some type of, optical inspection, people inspection, and those systems, the historical systems before deep learning, you had to hand code all those variables. And it took people, weeks or months to say, this is exactly what a circuit board looks like. This is exactly what my chair is supposed to look like. This is the variance in it. And when you make a minor change because your industry changes, you've got to start that inspection process all over again. With deep learning, you just say, here's the new golden sample, make sure it looks like this, because you had all that data. And I think, part of the reason that deep learning is so exciting and something that, most of you could relate to in this room is, what have we all told you to do with data over the past, 5-6 years? Don't throw away data. It's extremely important to your business. You can get value out of it. Then what did everyone do? So everyone saved data. It was great for storage, vendors, great for a lot of things. Well, you had this huge lake of data. Now, how do you extract value from that? And deep learning, as was stated before, allows you to comb through that data and find interesting, patterns, interesting, answers from that data. And the reason I think we've had this, big boom in AI, and partially while we're here as NVIDIA and great partner of IBM, is it's only been in the past couple of years that you've had enough processing power to actually do deep learning. And that's why, while deep learning and AI has been around forever, the theories have been around forever, but it took you weeks and months to get a result. And now, with the doubling, tripling of processing power that we've seen with GPUs and with partners like IBM, you can actually get results in minutes, in hours, things, I talk to customers that have come to our shows and they said, we've been running deep learning experiments, but, our training time took 3 weeks. Now with, new hardware, it's taking an hour. And, when you think about your own business problems, if you told your boss, I can get you that answer you want in 3 weeks, he's gonna say, no, go away. But if you can say, I can give you insight out of my entire customer base and ask me that question and I'll get you a result in 2 minutes, that's exciting, and that's what we're starting to see clients do is, what problems are the biggest things to solve? Is it customer service? We've all talked about chatbots, things like that, really helping enterprises be more productive and helping, people augment their staff with AI.
Yeah, one of the aspects that often gets lost in the conversation around AI, particularly as we're in this kind of hype phase, is the role of humans and AI, and how AI is best used in many cases to augment humans. And Charlie gave the example of using deep learning and AI to interpret radiology images. And in fact, the studies that have demonstrated this, the actual results of those studies were don't quote me on the numbers, but something like a radiologist interpreting an image to determine whether a tumor is cancerous is, let's say 90% accurate. The computer alone is, say, 92, 93% accurate, but the radiologist working with the human is on the order of 95, 96% accurate. And that's a result that we've seen across numerous of these types of studies, and I think it says a lot for how we as organizations should be thinking about adopting AI and really pairing AI, using it to augment the intelligence that's already in our organizations.
I'm so glad that we're not all going to lose our jobs to robots. Thank you for clarifying that, Sam. But I want to go back to something that Charlie mentioned. You threw out the word data lakes, and that's one of the questions that I get quite a bit from our IBM clients. And Nadeem, this one's for you. Mm-hmm. How important do you think it is to have a clear data and data lake strategy before you embark on AI? And where does really advanced analytics end and AI begin?
Yeah, it's a great question which you're asking. If you think about that, what Sumit mentioned, what Sam mentioned, what Charlie mentioned, everybody's talking about the data. Without data, you cannot do AI, you cannot do deep learning. And when you're talking about the clear data strategy, you really need to figure that out, that how you gonna ingest the data, how you gonna store the data, how you gonna clean the data, how you gonna apply the regulations and compliance around the data, because you don't want to kind of expose your data to a way which is going to be detrimental for the business. And on top of that, if you look at that, when you're talking about from AI perspective, AI giving you a decision. It is your clear data strategy. You're going to figure it out how to monetize that decision. And that's the key thing which you really need to think about, that like whatever I'm learning from my model, from machine learning, how I'm going to apply that in a near real time or real time for decision making. That's all. If you think about it from that, it's end-to-end pipeline you are building here. And in a lot of time when you're talking about, we're all getting into a highly compliance oriented environment. And one of the things which is going to keep coming back to us is that, how did you make this decision? Show me the lineage. Why did you make that decision? Because if AI is making a decision, there is still going to be regulation, there is still going to be compliance, that especially in highly regulated industries, that why did you make this decision? How did you come up with that? And there is going to be regulators asking you to go back to the original data, how did you make that decision? And at that point, you're going to figure it out, what was the reason why that particular algorithm, that particular machine learning algorithm picked that model and decide that. And the other aspect in that whole equation, you will very quickly realize that why these clear data strategy is very critical. It's garbage in, garbage out kind of model. If you think about that, if you are feeding, you really need to kind of feed a good quality data to your algorithm. Leave alone deep learning for a side, because deep learning is a totally different area altogether. Over there, you are throwing a lot of data and letting machine decide that. But if you look at from the pipeline perspective, you can use deep learning as part of your data quality initiative itself also for data cleansing purposes. It's not all about that you are doing towards the end. And it is not, as Kim is asking, where advanced analytics end and where AI starts. There is, to be honest, you don't need to kind of say that I have advanced analytics, or I'm truly going to go into AI space. And I have seen customers who don't have a good analytics strategy, and they're saying that, oh, we're going to directly go into AI space. That is, guys, the killer. Because one of the biggest problem, as Sam was mentioning, that human and data and your machine learning all work together to make a decision. And the key thing which when you are thinking about from applying any AI or machine learning model, you really need to figure it out, what value you are trying to extract from the data. What is your real problem you are trying to solve? Somebody need to understand the data to kind of tweak, build those models accordingly to get benefit out of that data. And second thing which, as I mentioned, like you should not say that AI is most advanced stage for me. I have seen that customers, when they are ingesting data, they are actually applying machine learning and AI even at that stage to do data matching, equity resolutions, data resolution. Because now you're getting so many different type of data. You're getting sensor data, you're getting social media data, you're getting your regular data sets, legacy data sets. Somebody has to do the matching of the data to figure it out which belong where. And the amount of data which is growing is making it very, very difficult for organization to do that work through humans. You have to apply machine learning, and in some cases even deep learning, as if you are getting into NLP space, if you're getting into more images and those kind of situation where you are constantly doing video streaming, you're constantly trying to get value out of that data set. You really need to kind of join that data, cleanse that data to feed that to your model. So according to me, clear data strategy is a foundation to truly monetize your AI strategy. And another thing which make it really, really great is that, I guess everybody mentioned, what is the primary thing you need for deep learning to be accurate? Ton of data, lot of data. It is all depend that if you say that I'm going to make a deep learning model, but I only have a few thousand row of data, I'm going to make a decision. Your deep learning model is not going to be as good as it could be, because it goes back with Sumit's example that if you're just going to feed him only pictures of dogs or a couple of animals, that model is only going to know that much. So that's a key foundation. And that's why your clear data strategy, capturing data to in the purest raw format, is critical. Capture the data from your IT sensor, capture the data from your social media, document structured, unstructured data, and then decide where you want to apply a traditional machine learning, where you're going to apply analytics, where you're going to apply deep learning, and that will give you very holistic AI vision and strategy.
Great thoughts, great thoughts. So one of the things, so I just did a study of about 100 early adopters of AI and machine learning. And one of the things that came out of that study was that people are starting to dip their toe in the water by leveraging the infrastructure that they currently have on premises right now, right? Because that's what's at their fingertips. It's what they can access. Sumit, is there anything that you can touch on in terms of where you should be trying AI? What are the right types of infrastructure? When should you be looking at the cloud versus when should you be looking at kind of a DIY, on-prem strategy?
So I think, all of this, Nadeem's point was the same point, which is everything follows the data. If you have a data strategy for the cloud, then you'll do it in the cloud. But if your data is on-prem, so if it's on a, point of sale, it's on some sort of system of record that's sitting on-prem. For example, if you're building a recommendation engine, you're a retailer and you're trying to build a recommendation engine for your website, you're looking at previous sales data, you're looking at current browsing, right? To your point on structured and unstructured data, right? So you're looking at, okay, what pages have I just visited? What do I already have in my cart? What is my buying history? What is people like me's buying history? In other words, my socioeconomic group. What is people from my, where I live buying history? All that kind of information, as much information as you can kind of piece together. So it just depends, where is all that data? If that data is on-prem, it's obviously better to start on-prem. If that data is in the cloud, then that's where you'll start. I think to the point of infrastructure though, this is a computationally intensive problem, right? Machine learning runs typically only on CPUs, but deep learning is completely running on accelerators like NVIDIA's GPUs, right? And the reason is, when you have lots of data and you have to crunch through it, you need compute capability, you need compute power, right? That's the bottom line. So whether you do it on-prem or in the cloud, typically you're using some sort of GPU infrastructure to actually run deep learning, or at least to train the models.
And just to add to what Sumit is saying, that you really need to make it, when you are making that decision, do it wherever your majority of the data is. Do not move data just for the sake of that. I want to do machine learning and you move the data from on-prem to cloud or cloud to on-prem because you have a more compute over there. That could be very cost prohibitive in a lot of cases, especially when you want to move data out of cloud to on-prem. That could be pretty expensive. And not only that, it goes back to Charlie's point, then it might take you a few weeks to even move the data. So those are things which you really need to consider when you're thinking about where to do it. And a lot of time, cloud is a great option. If the data, the best place according to us from the customer perspective, where they are pushing that, where the data is landing. Try to do it as close to that data as possible, because then you are not doing data movement. Here we are talking about terabytes and petabyte scale data sets when you're trying to do deep learning.
One other point on this, since we're talking about how to get started in AI, I think, when we think about the AI that enterprises will ultimately adopt, it's kind of like an iceberg. At the top of the iceberg, what we see are going to be, these AI solutions that the enterprise is developing around their specific needs. But the bottom of the iceberg, under the waterline, are going to be all the other ways that that enterprises adopt AI technology or absorb AI technology, and a lot of that's going to be coming from and embedded in solutions that you're acquiring, like your CRM systems, ERP systems, and other things. And so as you're starting to, as we start to evaluate, these systems, one of the things that we want to do is to start to look at, to what degree do these technologies, do these offerings increase our organization's, AIQ, like IQ, but our AIQ, and kind of build that into our evaluation matrix. Do they help our organization become more competent from an AI perspective without having to build it all ourselves?
Charlie, anything from that same discussion in terms of data?
I mean, the question I get asked most often is, how do I start? Image recognition is something that is broadly talked about, but for our day-to-day enterprise work, most of us in this room aren't looking at images for analysis. You're looking at data, you're trying to make predictions. In my previous jobs, I had to look at, who do I sell my next product to against a 400,000, user, customer database. And, part of AI, it seems daunting. You're like, I've got all this data, what do I do with it? But there's so many small projects that you can get started in your company, and that's probably the biggest recommendation that I have. Whether it's on-prem or in the cloud, it's actually really economical to get started. You could get started in the cloud, spend a couple $100, spend $1,000, and do a proof of concept. From our perspective, we accelerate deep learning, everything from our consumer grade, cards that, actually we're giving one away in the booth if you'd like one. But a couple $100, you can get started, and most of you are more senior executives here. But for your staff, you can make a fairly small investment to try something, proof of concept, and there's tons of available resources online, on our developer zone and on IBM's developer zone, and take that data, run that decision. You don't need petabytes of data to start with. You do need enough, but there's tons of great examples of, whether it's, natural language processing, whether it's text processing, that you can see, hey, does this model work? Does this idea work? You can show it to your boss. I've seen people do it in an afternoon. There's online courses that you can take, and in 2 hours, you've done a deep learning experiment. And start to think about, so where's the next small project to apply? Don't boil the ocean, but see success, and then start to look at, well, if I want to grow this, what infrastructure do I need? But the starting infrastructure, you don't need $1 million system. You can start with a few dollars in cloud, or a few $100 add-on to systems you already have.
Interesting. So, speaking of getting started and trying, a little at a time, what it sounds like, you've seen some mistakes out there. Sam, Sumit, are there some mistakes that you see people making early on that you can share with this group so that they don't walk down that same path?
I think the number one thing I see is making it too complicated too quickly. And this is referencing a point I made earlier. You can go pretty far with simple models if you start with a specific business problem as opposed to starting with, hey, I'm going to do deep learning and try to apply it in various places. So for example, a common, Charlie mentioned, something like, lead scoring or opportunity scoring. Those types of use cases can be often tackled with very simple machine learning models that also have advantages like explainability that we talked about, without trying to kind of force fit them into something more exotic like deep learning. So really understanding what the business problem is, and then starting to look for the simplest possible solution to that business problem is, I think, if you get that wrong, then you end up wasting a lot of time and money.
And
Go ahead.
Yeah, I was just going to add to what Sam is saying that, and if you really want to kind of get a blueprint for that, what is the kind of right thing to do? Generally, if you think about that, majority of the organization start with the descriptive type of analytics. Then they get into diagnostic type, and then they get into prescriptive and predictive. If you think about that, that is a really, if you think about from overall strategy perspective, that gives you a good roadmap how and where to start thinking about from machine learning and AI perspective. Because that will step by step help you understand your data and then push it to the next level. Yeah, now I understand if I automate this thing, I could address X, Y, Z. And if I do X, Y, Z, I can then address, it is going to impact my business this way. So you start thinking about that and slowly start implementing those models. And that will kind of give you a very good framework to start thinking what is the right way to kind of start with machine learning, AI kind of thing, and what is the applicability. It is constantly touching the data and feeling that what is the outcome of that.
Yeah, the only point I was trying to make, I think I'm echoing a little bit of what you guys are saying, but I always suggest that look, if you can create a simple case and solve it yourself without machine learning, just, logically, right? If someone buys this, they typically buy this, right? Just looking at the data a little bit. If you can do that, then it's probably a good problem to go solve using machine learning or deep learning or predictive analytics, right, to your point. Inventory management. If you can look at inventory management and say, if I did the following things, I would optimize my inventory, right, then that's a good problem. The mistake people make is, boy, I want to do inventory management. I should really take weather into account. Oh, and social media is trending. Let me make sure that I'm always on top of what Taylor Swift is tweeting about, right? So you start bringing in too many variables too fast. Now you should have a roadmap to that variables, right? You should have the vision that you will eventually get there.
Right.
But start simple. Start with something that logically makes sense to you, especially if you're just getting into AI or predictive analytics right now. Start with something, a low-hanging fruit, like you said, Sam, too. And that will make you successful and also give you the confidence to do something bigger and more bold.
Excellent. Excellent tips. So let's open up the questions to the audience. Does anyone have a burning question for our esteemed group of panelists here? We've got a mic floating around in the back, so just raise your hand. Here he comes. Right there.
Hi. You spoke about some of the issues around AI, and I have a pet peeve. I would think they should transpose those words. You spoke a little bit, Sam, about kind of intelligence augmentation, right, earlier. But can you talk a little bit about caution around predictions, particularly understand the difference between correlation and causality, and then when feeding the data in, about human biases and how that might affect your predictions?
Yeah, I think, so the question was around, there were several questions in there actually, but so one is around human biases and how they play into predictions, and this is a very hot contemporary topic in the field, and a lot of conversations are happening around it, and it stems from the point that was made earlier, and that is, all of this machine learning and AI stuff, fundamentally starts from the data. And so if, I think garbage in and garbage out was mentioned as well, right? And so if you feed in, for example, if you feed in biased data, you're going to get biased results. And some of the examples that there have been a number of examples of this in like natural language processing, for example, where you feed in historical text and you ask a system to make predictions, and the system makes bias predictions or biased associations based on that input data. And so that is something that's very important to consider. I'm seeing, I don't think there's like an established kind of set of best practices around that, but there are a number of folks that are starting to look at, creating a checklist of, how to make sure your data is, de-biased, and there are conferences and things like that are starting to spring up. But it's definitely an important topic.
Well, there was a joke or going around on Twitter. There was an image, and this may not be in fact true, but someone may have photoshopped the whole thing. But they had what Google predicted and what Amazon predicted. So Google said, cute puppies sitting on cushions. Amazon said, silk satin cushions with puppy on top. Google had been trained using our photos, Google Photos. People upload photos of their puppies, so it was biased toward recognizing puppies and cuteness. And Amazon is a retailer, right? Now, of course, this could have been some hoax joke email, but I think it goes to the point on bias. And there is no magic answer here. You just have to be very cognizant about making sure that the data that you're giving is rich enough that you're going around biases. Now, it's an active area of research. I know IBM research is working on it. I know Google and others are are working on how we could systematically improve or reduce bias, but it is no magic bullet as far as I know.
And I guess one other way a lot of people do that, when they are training the data, they use different samples. They don't use just the same sample every time when you're trying to run through different iteration. That's very common technique to minimize the biasism kind of aspect. And the second thing is that you have to constantly calibrate your model. So once you train the model, you test the model, it gives you a certain level of confidence. But when you deploy that in production, it's not that that model is done now. You have to constantly keep an eye on that. You have to constantly calibrate that data. You need to feed in more test data to train it and understand the model better and see where it needs calibration and tweaking.
Yeah, and I think it's an important point that AI isn't a one and done.
Exactly.
You train a model, you get a great result, you deploy that model, but the power of AI is it can always improve, and that's something as you think about your AI project, it isn't I have an end point, I have a deployment point, and then I improve over time from that. So something to consider as you're deploying projects.
Yeah, great. So Zach, I think we've got time for one more question out in the audience. Anyone else have a question for the panelists?
Zach is getting a good exercise.
I know, exactly.
So just to add on to that question, we're not really talking about AI, because wouldn't AI understand that there were biases coming in and possibly coming out? So predictive analytics is not really AI. I mean, AI is the Turing test, right? So we wouldn't be able to understand if we were talking to a human or an advanced intelligence.
Well, I think we're on a journey, though. We don't have the perfect AI today, right? So the image example I just gave you of Google versus Amazon, one day they'll become really accurate, right? And to Charlie's point, everyone is constantly retraining their software, their AI models. So, for example, Google Voice is constantly improving. Apple Siri is constantly improving, right? And I think it's just a journey. So your models will constantly evolve. They'll become better as you feed it more data, as you point out more errors to it. So people are trying to build self-driving cars, and the way they're building them, a lot of them they're driving the cars, right? And when the car makes a mistake, they tell it that was a mistake, and now it learned a new scenario, and so on. And people do simulations and all kind of stuff to learn faster. But the point is, your AI model is only as good as the amount of training it's received. Just like I am as good on tennis as much time as I spend playing tennis. Right?
And that's why...
Besides skill.
I totally agree with Sumit here. And a couple of additional points there. What you're speaking of is a specific type of AI that's usually referred to as artificial general intelligence or general artificial intelligence. It's the idea, it's kind of like science fiction AI, like it's a thing that is alive and sentient. But when we talk about AI for industry purposes today, we're very far from that. We're talking about AI in specific use cases that is trained by us using data to do very specific things. One additional point, going back to the original question as well, is the dirty secret for a lot of these, like the Silicon Valley AI implementations, is that there's often tons of humans in the back actually, making believe they're the AI. So you're interacting with this bot. The bot is really front-ending a call center or a chat center that, all it's really trying to do is to save the humans from answering the 20 to 80% of questions that are rote and repetitive, and making it so that the customer service agents only have to deal with the things that are unique and require that human intelligence. So, we're far from, that kind of AI that's going to be standalone and solving every problem.
To the point of bias earlier. Sorry.
Well, so Sumit, I hate to cut you off because we could go on forever here, but we are out of time. So I want to thank you guys. And I wanted to just leave the audience. As I was thinking through this idea of the hype of AI over the last few days getting ready for this, I read a great quote by Bill Gates. And he said, we always overestimate the change that will occur in the next 2 years, and we underestimate the change that will occur in the next 10. So don't let yourself be lulled into inaction. So I want to just kind of leave you guys with that thought as you think through what these experts have talked about today and how you can get started. Think about that change that's coming over the next 10 years and start to dip your toe in the water and play around with deep learning, machine learning, and AI and get started. Our panelists will be down here for more questions, and Zach's going to be announcing the winners of our drawing right now before we wrap up.
So the winners are 616326.
We have a winner. They're winning Bose headsets.
616341. 616. Oh, sorry. 314.
I feel like it's the Price is Right here.
268293.
All right, another winner.
And we have one more over here. And
Did we get all the winners, Zach, or we still got another to announce?
we have one more.
Okay, last one.
268278.
All right, well, thank you guys for attending. We'll be down here if you've got questions.